us look at the simplex method. So if your objective function will be from c1 x1, c2 x2, so on, cn xn. This is your objective function with given constraints. Constraints are a1 x1 plus a12 x2, so on, less than equal to b1, a21 x1, so on, less than equal to b2, so on, amn x1, so on, amn xn less than equal to bn. If this is your objective function, if these are constraints, if you want to maximize, the algorithm says as introduction of non-negative slack variables to make the inequalities into equalities. Okay, so that is step number 1. Let us start with the problem so that we will do the step number 1. So the problem is maximize. The problem is maximize 6x1 plus 4x2 subjected to 2x1 plus 4x2 less than equal to 14, 6x1 plus 3x2 less than equal to 11, x1 comma x2 greater than equal to 0. Maximize this function by simplex method. So the problem is given. Now let us solve the problem. The problem is 6x1 plus 4x2. This is the objective function given. Now the constraints are 2x1 plus 4x2 less than equal to 14, 6x1 plus 3x2 less than equal to 11, and obviously x1 x2 greater than equal to 0. Now this problem we have to solve by simplex method. Now the problem is, look at the problem, maximize. So it is the maximize, and the function will be in this form. Constraints are in this form. Now let us start with the step number 1. Step number 1 says convert the inequalities. What are the inequalities given? This is the inequality, equation 1, inequality, equation 2. Now we need to convert these two into equalities. How I will convert? See, the inequalities given are 2x1 plus 4x2 less than equal to 14, 6x1 plus 3x2 less than equal to 11. Now these two equations are converted into equalities by introduction of some slack variable. So this inequality is made into equality. This inequality is made into equality by adding some non-negative slack variable. Here now, step number 1 says, what is step number 1 says? Make your inequalities into equalities by adding some non-negative slack variable, means positive slack variable. So this equation is having inequality. Let us make it into equality by adding some variable called x3. Because the equation is consisting of only two variables x1 x2, I have added some x3. Now this equation is also inequality. I have added some variable called x4 so that it will be equal. Less than equal becomes equal. If you have one more equation, what to do? You will have one more variable called x5. One more equation, you will add x6. Oh fine. So that is the step number 1. What is step number 1 says? Convert your inequality into equalities by adding the non-stack variables. Fine. Now after adding this, you make here a small table of mentioning your Ci and then Xi. You have added Xi as x3, x4, and initially you don't know the value of x3, you don't know the value of x4. Let us write like this. You have added x3 value into the problem because x3 is not given the problem. You have introduced the problem x3 into the problem. You have introduced a variable called x4 as a non-stack variable. So initially you don't know the x3, x4 value, so let us keep it as 0, 0. Clear? Step number 1, fine. If step number 1 is over, then I will go to step number 2. Step number 1, read down. Whatever may be the equations given, add these slack variables to make it into equality, and whatever variables are added, you reflect on the left side. If you have one more equation, write x5. 0, x6 0. Because the problem is only two equations, I have two variables added. Clear? Now step number 2. Now along with after completion of this step, what we do is we will write the coefficients matrix. We will write the coefficients matrix. What is the coefficients matrix? I will write like this: C x1, x2, x3, x4, and b. Because the equation constraints for this problem are in this form: a1 x1, a1 x2, a1 x1, result of b1. So let us write a table of coefficients. Now what is the first equation quotient? X1 quotient 2, x2 quotient 4, x3 quotient 1, x4 quotient 0. For this equation x4 is not there. What is b? 14. Similarly, second equation x1 quotient 6, x2 quotient 3, x3 quotient 0 because there is no x3 in this equation. But whereas x4 is 1 and this is the result. Is it okay? Step number 1. Step number 1 is okay. After adding these slack variables, write on the left side this one, then write all the coefficients in this small table. Clear? Now step number 2. Note down. Read off a feasible solution. Read off a feasible solution and insert it as the second row. Insert it as the second row below the table. An obvious solution involves only variables whose columns consist of 1 and rest 0. An obvious solution involves only variables whose columns consists of 1 and the rest as 0. Full stop. The solution being the value of b at the row where the single entry appears. The solution being the value of b, that is small b. The solution being the value of small b at the row where the single entry appears. Where the single entry appears. Full stop. The variables this feasible solution are called basic set. The variables this feasible solution are called basic set. And write feasible solution before feasible solution the coefficients of objective function. Before feasible solution, the coefficients of objective function as Cj. Before feasible solution, write the coefficients of objective function as Cj. Now I am just reading the step number 2. Step number 2 says read off a feasible solution and insert it as the second row below the table. See, this is the table. Now below the table in the second row we need to write the feasible solution. That is what they are saying. Feasible solution. Now, how to get the feasible solution? He is saying. How to get the feasible solution? Read off the feasible solution and insert it as the second row below the table. If this is the table, first row, second row. Second row, I need to write the feasible solution. Fine. How to get the feasible solution? He is saying, see, an obvious solution involves only variables whose columns consist of 1 and rest 0. Look at the columns. Look at the columns. This column, first column, second column, third column, fourth column, fifth column. Now, which columns has 1 and 0 that has the solution? Rest of them does not have the solution. That is what the definition says. Columns having 1 and 0. Is this column having 1 and 0? No. Is this column having 1 and 0? No. This column having 1 and 0. So this column has the solution. This column has solution. So for this column there is no solution 0. For this column there is no solution 0. But this column has some solution. Again this column also 1 and 0 is there. It has some solution. Now how to write the solution he is saying. How to write the solution? In the next one he is saying the solution being the value of B. The value of B at the row where the singularity appears. What is the solution? The solution says the value of B at the row where the singularity appears. For this column, where is the singularity? This one. For this column, this is 0. This is the singularity, that is numerical 1 is there. So in this row, what is the value of B? 14. That will be your solution. Now let us look at this column. In this column, here we does not have any singularity. Here we have the singularity. Now what is the value of B? That will be the solution. Is it clear? The first part of this step number 2 says writing the feasible solution as the second row. Writing the solution as the second row. How to write the solution? The solution says only the columns with having 1 and 0. This column does not have 1 and 0, so keep 0. This column also does not have 1 and 0, 0. This column has 1, 0, so it has some solution. This also has some solution. Now how to get the solution? Solution says the row where the singularity appears, the value of B. Because this singularity appears, so what is the value of B? That will be the solution. In this column, this is the singularity. Now what is the value of B? That will be the solution. That is now second row. Now what is the first row? First row says write the coefficients of the objective function as Cj. So I am writing as the first row as Cj. Now what is the coefficients of the objective function? Where is my objective function? This one. 6x1 plus 4x2. So x1 coefficient is 6, x2 coefficient is 4, and there is no x3 in the objective function. There is no x3 in the x4 in the objective function. Is it okay? So this is step number 2. Is this step number 2 clear? Step number 2 says writing the feasible solution as a second row. Writing the feasible solution as a second row. The feasible solution is only for the columns whose has 1 and 0s. Rest of the columns, the solution is 0. So if any column does not have 1, 0, you should keep directly 0. If any column has 1 and 0, then take the row where it has the B value that has the solution. That is the second row. Now what is the first row? First row is write Cj as your objective function coefficients. Your objective function coefficients are x1 is 6, x2 is 4, and there is no x3 in the objective function, and there is no x4 in the objective function. Is it okay? Step number 20 down. Step number 20 down. Because these steps you have to repeat. If you are clear itself, then you can repeat again. If you have any doubt, let us know. Step number 1, adding the slack variables. Step number 2, writing the feasible solution. Now step number 3. The feasible solution is now tested for feasible solution is now tested for optimality. The feasible solution is now tested for optimality. Each variable which is not part of the feasible solution is evaluated by computing delta J. Now what is delta J? Delta J is equal to Cj minus sigma Aij into Ci. Sigma Aij into Ci. So there is a difference here. This is Ci, this is Cj. Don't confuse. This is Cj, this is Ci. Okay. If one or more of the delta J are positive, if one or more of the delta J are positive, then the feasible solution is non-optimal. Then the feasible solution is non-optimal. If delta J less than or equal to 0, if delta J less than or equal to 0 for all J, if delta J is less than or equal to 0 for all J, then the solution is optimum. Then the solution is optimum. And simplex method terminates. Simplex method terminates. The solution is optimum and simplex method terminates. If not, we go to step number 4. If not, we go to step number 4. Now what is step number 3 says? Step number 3 says, after step number 2, now whatever the feasible solution is tested for optimality. Whether we got optimum or not. How to check for optimum? He has given to calculate delta J. If delta J is less than or 0, you got the solution. Optimum is reached, we can stop, terminates. Algorithm terminates. If delta J is either not 0 or it is not less than 0, that means any positive number it comes, then it is says non-optimum. You have to go to step number 4. This is called step number 3. Okay. So what is step number 3? Step number 3 is calculation of delta J. And that delta J, if it is either 0 or less than, that is negative number or 0, your program ends there. You got optimum. Otherwise, we need to proceed to the step number 4. Otherwise means what? If we got any delta J value as positive number, then you are in non-optimum state only. You need to go to step number 4. Now let us calculate delta J from each values. Maybe I can write delta 1. Delta 1 is equal to C1 minus sigma I equal to 1 to 2, because there are only 2 equations. So 1 to 2 means A11 C1 plus A21 C2. Is it not? If I use sigma, this will be A11 C1 plus A21 C2. Okay? You see, look at I value I am varying. I value, I is 1 and next I is 2, because I is 2. I am only doing for J equal to 1 case. J equal to 1, so C1. J equal to 1, C1. Now J equal to 2, C2. So let us keep the values what we have. What is C1? 6 minus 2 0 6 into 0. Is it okay? Cj, already I written Cj. These are called Cj's, objective function coefficients. Ci, already we have written Ci. Ci, these are called Ci's. So initially for x3, x4 there are Ci's are zeros. So 0, 0. Now what is A11, A21? A11, first row, first column. First row, second column. Second row, first column. Second row, second column. Is it okay? First row, first one. Second row, first one. Second row, first one. Is it fine? So first I have elaborated, then I have used the coefficients. Now this is for j equal to 1. Now calculate for j equal to 2, that is delta 2 equal to C2 minus A12 C1 plus A22 C2. So what is C2? 4 minus 4 into 0 plus 3 into 0. So what is this value? First value is 6, second value is 4. Is it clear? Step number 3, very crucial of calculating delta J. First understand the formula of delta J. Delta J is equal to Cj minus sigma A Ij into Ci. Sigma A Ij into Ci. Here I is varying. Because we have two equations, I will run from 1 to 2. So let us keep I1, A1. Next, A2. That's all, because two equations have, so A1 to 2 it will A1. Next I will become 2. But I am starting with J1 case, so J will be 1, J will be 1, I will be 1. When I is 2, it will be 2. Now because this is Ci is this one. Now this is Cj, Cj is this one. So Cj, what is J1? 6. Cj, what is J2? 4. Cj, what is J3? 0. Cj, what is J4? 0. So I did for J2. Now you do for J3. Similarly J4. Calculate the delta, what is called delta 3 and delta 4. Calculate for J3, J4, what is the values? What is delta 3? Delta 3. That is, what is delta 3 formula? Submit. Tell me the formula for delta 3. C3 minus A. Very good. 1 3 into C1. Next. A23 into C2. Now let us find what is the value of C3 here. This is Cj. What is C3? J3 0 minus A13 13 1. So C1 0, C2 0. So if 0 is there, whatever the value will be 0. Already 0. So delta 3 is 0. Now what is delta 4? Delta 4 formula. Delta 4 formula C4 minus A14 C1 A24 C2. Anyhow C1 C2 initially are zeros. This will be 0 and C4 for J4 is 0. Cj are coefficients of objective function. coefficients of objective function. Don't confuse with Cj and Ci. Ci are basic set variable. Basic set variable, that is, we have introduced the slack values. Initially we does not have any values, we have zeros. So those values are called Ci values. Cj values are the coefficients of the objective function. Now look at the values of delta J now. We got all zeros are less than values. We got all zeros because this says if delta J is less than or 0 for all J, then you have got solution. Look at the delta J value, positive value you got. If you got at least one positive value, gone. You need to go to step number 4. Of course, you got two zeros. Delta 3 0, delta 4 0. Delta 3 0, delta 4. But at least you have one positive value. This says for all J, you need to get either 0 or less than values. If any of the one value is positive, then we need to move to step number 4. Step number 3 is okay. Step number 3, any doubt? Because you need to repeat this again. Step number 3 is calculation of delta J. Delta J formula is Cj minus sigma Aij into Ci. See here only two equations. Only two terms are coming. If three equations, three terms will come. Four equations, four terms will come. You need to vary only I, not J. J will be reflected here itself. You have to take J values from this one. You have to take I values from this one. From every step these will change. You will see now. Clear? Step number 3, read out. I'll pause here for some time because you need to repeat for step number 3 because it will rotate. Step number 3, read out. Step number 3, finding the optimal solution by evaluating delta J. For all delta J, either 0 or less, the solution is reached. Optimum value reached. Simplex algorithm terminates. Otherwise, go to step number 4. How to calculate delta J? Use the formula. Use Cj, Ci's. Cj are coefficients of objective function. Ci are the basic set values. Okay. Now step number 4. The variables with the maximum delta J delta J is subjected to enter the solution in the place of some variable, already in the solution. In the place of some variable already in the solution. The variable to leave the solution is found by computing bi by aie. Computing bi by aie. By computing bi by aie, where e is called entering variable. called entering variable. The variable with the smallest bi by aie will leave. The variable with the smallest bi by aie will leave. I am repeating again step number 4. The variables with maximum delta j is selected to enter the solution in the place of some variable already in the solution. Full stop. The variable to leave the solution is found by computing bi by aie, where e is called the entering variable. The variable with the smallest bi by aie will leave. Is it clear? Now look at step number 4. Step number 4 says there is some variable will leave from the solution, some variable will enter into the solution. That is what he is saying. Clearly read of the step number 4. Some variable will enter, some variable will leave, which is already in the solution will leave, and in place of that some variable will enter. Now he has clearly given which is entering, which is leaving. First line says the variable with the maximum delta j is selected to enter into the solution. Now what he did, after writing this table, after writing Cj, after writing feasible solution, I have written delta j values which is computed from step number 3. What are the delta j values which is computed from step number 3? We got 6, delta 1 has 6, delta 2 has 4, delta 3 is 0, delta 4 is 0. I have written like this. Now what is first line of step number 4 says? Maximum delta j. Which is maximum delta j among this? So this maximum delta j will enter into the solution. Enter into the solution, that means this variable will enter into the solution. In place of some variable will leave the solution. Maximum delta j turning to x1. So x1 will now enter in place of some variable already there in the solution. How other variable which is leaving, how to find out? He has given that. He has given the variable to leave the solution is computed by finding bi by aie. Already you know b values. You need to divide with a values. How that a value? How that a value? Entering. What is entering? This is entering. Now this entering, what are the a values? These two are the a values. Now we have to divide that. That means 14 divided by this a value 2, 11 divided by this a value 6. Now what is the values? 14 by 2 is 7. This is something about it. Now what is saying? The variable with the smallest pi by aie. Among these two, which is the smallest? This one. So this will leave the solution. This will leave the solution. So this will now leave the solution. So now x4 is leaving. X4 is leaving. X1 will enter. X1 will enter. With whatever Cj value is there, it will enter. So that means what? Your table now changes. That table now changes to. Your table now changes to. X3 will be as it is. But here x1 will come. X1 will come here with whatever the Cj value is there. Rapid function value will come. So your basic set has changed. Initially your basic set is this one. Now your basic set has changed from step number 4. Step number 4, again I am repeating how to find out step number 4. See, already from step number 3 you have calculated delta j. Write those delta j values. Now after writing the delta j values, pick out the maximum delta j value among the given delta j, which is the maximum. That maximum which corresponds will enter into the solution with some variable already in the solution to leave. How to calculate some variable has to leave? You calculate bi by aie. You know b values. You need to divide with a. Now which a you have to divide? Either this or this or this or this. No. You have to divide the variable which is entering those a values only. So you have to divide with only 2, not with 4. 11 with only 6, not with 3. Now after completing these two, which is the minimum, identify that. That will be leaving. So that is corresponds to x4. So x4 will leave, x1 will enter, x1 will enter with whatever the Cj value it will come. You see, x3 will be as it is, but it is entering x1, x4 left. Is it here? Step number 4. Step number 4, very important. If you have any doubt, let it clarify here itself. Calculate delta J value should be posted down. After the physical solution, post down. Find out maximum value. Find out A values. Divide that A values. Find out the minimum value. Just replace that one with the Cj value. Your basic set has changed. Okay. Okay, step number 5. The table is now modified. The table is now modified so that the entering variables will be distinguished by having a 1 in the row the table is now modified so that the entering variables will be distinguished by having a 1 in the row of departing variable distinguished by having a 1 in the row of departing variable and 0 elsewhere. This is done by row manipulations until the job is done. I am again repeating step number 5. The table is now modified so that the entering variables will be distinguished by having a 1 in the row of departing variable and 0 elsewhere. This is done by row manipulations until the job is done. Now look at here. So what it says, clearly read off from step number 5. See, step number 5 says the table is now modified. Which table? Now this table is going to be modified. This table already modified in the step number 4. Now we are going to modify this table. How to modify this table? He is saying the table is modified so that the entering variables will be distinguished. This is the entering, no? So this will be distinguished. That means they want to show this table with the entering variables to be different from the other variables. How they are doing? Distinguished by having a 1 in the row of departing variable. So this is entering. Which is departing? This line is departing because this is going and this is entering. Now this where it cuts, this one should be made 1 and rest of them should be made zeros. The entering and the departing. So the entering departing row variable should be made 1 and the rest of them whatever may be there they should be made 0. In that way the table is modified by row manipulations. Is it okay? That means this 6 should become 1. This 6 will become 1. How it will become 1? R2 is equal to R2 by 6. Is it okay? Row 2 is equal to row 2 by 6. So 6 by 6 will be 1. Now R1 is equal to R1 is equal to R1 minus 2R2. Because this has become 1. Now this has become, already it is 2. So 2 has to become 0. How 2 has to become 0? 2 minus 2 times of 1. So R1 becomes R1 minus 2R2. If I do this manipulation, this will become 1, this will become 0. Step number 5 says, entering departing should be 1. You cannot make this as 1, this as 0. Entering, departing, where it cuts this one. So this should be made 1 and rest of them should be 0. See, for example, you have 5 equations. You should make this as 1 and remaining all you should made it 0. How you do? By manipulations. So this is become 1 by doing this and this is become 1 by doing this. Now apply to this row and tell me what is the table modified. So tell me what is R2 by 6? R2 by 6. This will be 1. R2 by 6. This will be 0.5 because 3 by 6. R2 complete row by 6. Complete row by 6. R by R 1. 3 by 6 is 0.5. This will be 0. This will be 1 by 6. This will be 11 by 6. Is it okay? Complete row 2 by 6. This I outlined. Is it okay? Now you tell me the values of this one. R1 goes to R1 minus 2R2. R1 goes R1 minus. So this will be 0. Now what is this value?
Minus 2.
3. So this will be 3. Now what is this value? 1. What is this value? Minus 1 by 3. This value 31 by 3. Okay, that table is modified now. How it is modified? The entering departing variable is made 1 and rest of them made 0 by using row manipulations. Is it okay? Is it okay? Now you look at the values. Now all the coefficients are changed. Coefficients are changed. So you can estimate now delta j and check whether all delta j less than or equal to 0, problem solved. If not, we need to again look at step number 2, which is varying, which is entering. So calculate delta j because these are varied. Calculate delta j values. I already told how to calculate delta j. Calculate. Delta j values, calculate. Now Ci values are not 0 0, 0 6. Ci value C basic set has changed. Fine. Cj values are coefficients of positive function. Those are 6 4 0 0 only. But Ci has changed. Coefficients A11 A12 has changed. Is it clear? Your Ci changed, A11 A12 those values are changed. So you calculate delta 1, delta 2, delta 3, delta 4 and check whether all the delta j's are 0 or less. First write the formula delta 1, write the formula delta 1, then substitute delta 2 as 1, delta 3 as 0, delta 4 as minus 1. Absolutely correct. How many girls have done? Now what are the delta J values? I write here. Now you have calculated delta J, you got 0, 1, 0, minus 1. So what is the feasible solution? Step number 2 says feasible solution is the columns which have 1 and 0 corresponding value of B, otherwise it is 0. Step number 2, much well applied. Feasible solution. So the feasible solution is the 1 and equal to B value, okay, 11 by 6. దీనికి feasible solution 0. దీనికి 31 by 3. దీనికి 0. Now all the delta J values, some value is not positive, so algorithm will not terminate. You got 0 minus 1, but one value, at least one value got the positive value, so will not terminate. Now what is step number 3? Maximum delta J will enter, minimum Bi by A will leave. So now this is the maximum value, so now this will enter here, this will enter, that means H2 will enter, and you have to calculate Bi by AIE. So what is Bi by AIE? 31 by 3 by what is the A value? Corresponding value of 3, you have to divide with 3, and corresponding value of 3, that is 11 by 6 by 0.5. Now what is the minimum among these? That will leave. What is the minimum? I am writing the answers also. You will get here 3.4, you will get here 7.3. So now this will leave because this is the minimum value. So this will leave. That means x3 will leave now, x2 will enter with corresponding Cj value here. That means your basic set now changed. Your basic set now changed. So your basic set now x2 come here, x2 with the corresponding Cj value 4. Already x1 is there, 6 is there. So your basic set has changed. Is it clear? See, one thing is very clear. I am telling you, this is the only simple method which you can come across in any of the textbooks. మీరు ఏ టెక్స్ట్ బుక్ ఓపెన్ చేయండి ఇంతకన్నా సింపుల్ మెథడ్ మీకు ఉండదు. You look at any textbooks by the simplex method. This is the only way which I have developed. I have run the program. I have solved several problems. ఇది కూడా మీకు అర్థం కాదని మీరు చేయలేకపోతున్నారంటే మీరు అంతకన్నా వేస్ట్. నేను ఏం చెప్పలేను. ఆల్రెడీ స్టెప్ బై స్టెప్ పాస్ ఇచ్చి మరి చెప్తున్నాను. మీరు ఇంకా డెల్టా జెడ్ పెట్టి ఫిజికల్ సొల్యూషన్ మీరు చెప్పకపోతే నేను ఏం చేయలేను. స్టెప్ బై స్టెప్ నేను పాస్ ఇచ్చి మరి చెప్తున్నాను. ఓకే, సో డెల్టా జెడ్ మాక్సిమం ఎంటర్ అవుతుంది, మినిమం ఏవి లీవ్ అవుతుంది. దీంతో నెక్స్ట్ స్టెప్ ఏంటి? వాట్ ఆర్ ద ఎంటరింగ్ వేరియబుల్స్ డిపార్టింగ్ వేరియబుల్ should be made equal to 1 and rest of them equal to 0 by row manipulations. అంటే ఏంటి? దీన్ని మీరు 1 చేయాలి, దీన్ని 0 చేయాలి. దీన్ని 1 చేయాలి, దీన్ని 0 చేయాలి యూజింగ్ row manipulations. అది చేస్తే ఏమవుతుంది? ఈ టేబుల్ మారిపోతుంది. ఆల్రెడీ ఈ టేబుల్ మారిపోయింది. ఈ టేబుల్ మారిపోతుంది. ఈ టేబుల్ మారిపోయిన తర్వాత మీరు మళ్ళీ డెల్టా చే కడితే అన్ని వాల్యూస్ లెస్ దాన్ ఈక్వల్ టు 0 వస్తుంది. అన్ని వాల్యూస్ డెల్టా చే లెస్ దాన్ ఈక్వల్ టు 0 వస్తుంది. చేయండి, ఇప్పుడు ఈ టేబుల్ మ్యానిపులేట్ చేయండి. What is the row manipulations? I can write R1 as R1 by 3 because this I have to make it 1. So by 3 is equal to R1. Similarly, R2 goes R2 minus 0.5 times of R1. ఎందుకంటే ఇది 1 అయిపోయింది కదా, 1 అయిపోయింది కాబట్టి దీన్ని 0.5 తో మల్టిప్లై చేసి అనుకోండి. 0.5 minus 0.5 0 అవుతుంది. ఎందుకంటే ఇది 0 చేయాలి. ఇది ఎంటరింగ్ లీవింగ్, ఇది 1 చేయాలి. Now using these manipulations your table will change. Now tell me the table, calculate. Tell me the table. Use row manipulations, change the table. So tell me the table change. Every x1 0, x2 1, x3 1 by 3, very good, x4 minus 1 by 9, b 31 by 9, very good. Now 1, this one 0, this one minus 1 by 6, this one 2 by 9, this one 1 by 9. Now table has changed. Table has changed. CI is changed. Calculate delta J. Calculate delta J. Now this time your delta J will become either 0 or negative. You won't get any positive. Calculate delta J. Calculate delta J. Your table has changed, CI has changed, so calculate delta J. Delta 1, delta 2, delta 3, delta 4. So you are getting all the either zeros or negatives. So your optimum is reached. Is it okay? No, still the problem is not over. Just you reach the optimum, but I didn't know what is optimum. After calculating delta J values, all your delta J values either zeros or negative values. So that means your optimum is reached. Now what is the optimum value? What is the optimum value? What is the optimum value? You write the feasible solution. Write the feasible solution now here. What is the feasible solution? Write the feasible solution here. What is the feasible solution? What is the feasible solution? 1 by 9 here. 31 by 9 here. 0. Now just look at the board now. Just look at the board. Your feasible solution says x1 as 1 by 9, x2 as 31 by 9, x3 is 0, x4 is 0. You started with x3, x4 zeros, you ended with x3, x4 zeros. You left with x1 as 1 by 9, x2 as 31 by 9. So these are the optimum values. x1 as 1 by 9, x2 as 31 by 9. Now these two values you have to keep it in your objective function. Objective function is something 6x, 4x, something values. You keep those values there, and whatever the objective function value you got, that is the maximum value from the optimum solution. Is it clear? So how we got the optimum? Writing the feasible solution. So you got x1, x2. Now substitute back in your objective function. That is your final maximum value. Now the same problem if it is asked yesterday in LPP graphical way. How we have it? You have drawn it, you have intersect, you got values at different points, and after finding at different points, what is the maximum you got? At what are the different points you got maximum? You can solve the same problem using graphical, you will also get the same value what you got from the simplex. అక్కడ ఏం చేసాము గ్రాఫ్ గీసాము షేడెడ్ ఏరియా కట్టాము ప్రతి పాయింట్ దగ్గర వాల్యూ కట్టాము ఏ మాక్సిమం అది మాక్సిమం ఇక్కడ డైరెక్ట్ గా మీకు సొల్యూషన్ వస్తుంది దాంట్లో సబ్స్టిట్యూట్ చేస్తే మాక్సిమం వాల్యూ వచ్చేస్తుంది ఆ వాల్యూ ఈ వాల్యూ రెండు సేమ్ ఈక్వల్ అది గ్రాఫికల్ వే సింప్లెక్స్ వే ఇస్ ఇట్ ఓకే Understood? See, from unit number 5, either the same problem will be asked to solve by graphical or asked to solve by simplex. Simplex method ఇంతకన్నా సింపుల్ గా ఎవరు చెప్పరు. ఫస్ట్ పాయింట్. దీని తర్వాత వచ్చే వెర్షన్స్ ఇంకా కాంప్లికేటెడ్. అంటే దీని తర్వాత వచ్చేది డ్యూయల్ సింప్లెక్స్ మెథడ్ ఉంది, రివైజ్డ్ సింప్లెక్స్ మెథడ్ ఉంది. ఈ సింప్లెక్స్ మెథడ్కే మీరు కనుక్కుంటున్నాను. ఇంత నేను కాస్ట్ ఇచ్చి స్టెప్ బై స్టెప్ చెప్పి మళ్ళీ రీఎంటేట్ చేస్తేనే మీరు ఆడ. సో కెన్ ఐ డూ విత్ ద డ్యూయల్ సింప్లెక్స్? So I will give an assignment to you. You solve because I have explained the simplex with lot of things. Now let us you understand the dual simplex. మీరు చేసుకొని రండి. నేను అసైన్మెంట్ ఇస్తాను. డ్యూయల్ సింప్లెక్స్, రివైజ్డ్ సింప్లెక్స్. You can look at whichever textbook you want because you all are well matured, final year, lot of knowledge. Fine. So you solve on your own. I am just leaving to you dual simplex, revised